All right, welcome to screencast number 1 for Unit 4, Lesson 3. I'm on page 200. What of motion? By the end of this lesson, you should be able to describe Newton's laws of motion and apply them to real-world situations. So let's get started on that. Okay, I'm on page 202. How did Sir Isaac Newton contribute to scientific thought? Okay, have you ever heard the story of Isaac Newton and the falling apple? Isaac Newton was an English natural philosopher who laid the foundations for modern physical science. Legend has it that Newton had an insight about gravity after watching an apple fall from the ground. Well, that's not really important, but the thing that he figured out about gravity... Sorry about that, that was a spell. The thing he figured out about gravity was important. Gravity, he reasoned, pulled all things towards Earth's center and acted on bodies in space as well. And his work on gravity led him to develop his 3 laws of motion. Okay, at the red heading, Newton proposed laws of motion. Newton's laws of motion describe the relationships between forces, matter, and motion. Okay. These laws were published in the late 1600s in a set of books titled Philosophiae Naturalis Principia Mathematica, or simply the Principia. It was all done in Latin back then. Okay. Interestingly, Newton had contributed to the development of the branch of mathematics known as calculus the year before he published his book. Look at page 203. Newton's ideas helped shape the scientific revolution. In the Principia, the book he wrote, he set forth a scientific method that revolutionized how scientists conducted investigations. His method stressed the importance of careful observation, experimentation, and unbiased analysis. And these methods are still used largely by scientists today. Newton also invented a new type of telescope, the reflecting telescope, that eliminated the blurriness of refracting telescopes in use at the time. Refracting telescopes use lenses where light passes through them and is bent and focused. But a reflecting telescope uses mirrors, a curved mirror, to focus light. Okay. All right, so look at number 7. It says, use the concepts on these 2 pages to complete the cause and effect chain about Newton's work. So it says Newton develops the law of universal gravitation. The law of universal gravitation leads to the laws of motion. Laws of motion lead to Einstein's theory of relativity, which leads to a better understanding of nuclear energy and the origin and history of the universe, is what I put. Okay, so let me show you what all I've got. Okay, the reason why I have things numbered is because of number 5 right here. It says, as you read, underline ways in which Newton has impacted scientific thought and society. So up here I put a number 1 and I underlined gravity. He reasoned, pulled all things towards Earth's center and acted on bodies in space as well. Another contribution he made was his laws of motion. Newton's laws of motion describe the relationships between forces, matter, and motion. His book, the Principia, laid out a lot of these laws. Number 4, Newton had contributed to the development of the branch of mathematics known as calculus the year before. On page 203, number 5, I underlined in the Principia, he set forth a scientific method that revolutionized how scientists conducted investigations. His methods stressed the importance of careful observation, experimentation, and unbiased analysis. And a 6th contribution, Newton also invented a new type of telescope, the reflecting telescope. Okay, and then if you'll notice on number 7, I put down here that all of this led to better understanding of nuclear energy and the origin and history of the universe.